Up to this point, when we've been talking about linear equations, we've been talking about things like slope-intercept form. Which is y equals mx plus b. We've been talking about different things. We've been talking about arithmetic sequences, where we have f of x equals n0 plus our common difference times x. These are all ways that we've used to construct linear equations. But today I want to do a different one. And this is a lesson for 4.7, which is point slope form. Okay. And I've said this multiple times. Mathematicians are incredibly lazy. What do we need, do you think, for point slope form? We need a point and a slope. And that is it. And we'll be able to construct point slope form. So the basic form of point slope form is going to be this. Y minus y1 equals m times the quantity x minus x1. Okay? And so I'll go into what these elements are. What each of these elements are. Where m equals our slope, of course. M has been our slope in every form that we've looked at. So m is slope, but then x1 comma y1, this is our point. And then x and y stay as variables. X and y stay as variables. Okay? So, I mean, essentially what I'm going to be doing is I'm going to be telling you about these relationships. You know, I will say something like there is a point 2 comma negative 3, and there's a slope of 1/2. Write an equation based on this information. And so what you would do is you would look at your point slope form and you would just plug it in. You would say y minus y1. The y value of my point is negative 3. So I'm going to subtract a negative 3. That's the same as adding. So I'll say plus 3. Equals my m, which is 1/2. Times the quantity x minus x1. x1, the x of my point is 2. So it's going to be x minus 2. And that would be it. That would be that equation in point slope form. What are some advantages of this form? What's easy about this form? It's pretty simple. Okay, what are some struggles you anticipate with using this form? Yeah. Getting x and y confused. Yeah, making sure you have your x's next to your x, your y next to your y. Because it's weird, right? The y is on the left side of our equation, but y is on the right side of the point. So sometimes we might mix that up. What else is a point that might be confusing? Yeah?
When there's no slope but 2 points.
No slope and 2 points. What does that look like when you have a zero slope? Sure. And actually, that's a really good point. I want to kind of talk about that. That's a good little segue. What if there was no slope? Okay. What if I had the point was 2, 2, and I told you that the slope was 0. Okay. Well, now, if I were to do this into point slope form, I know that it's going to be y minus y1, 2, equals m times the quantity x minus x1 minus 2. And let's see what happens when we actually work this out. Well, 0 times anything is 0. So I have y minus 2 equals 0. So if I just solve for y, I have y equals 2. So what's y equals 2? That means I go up 1, 2, and I draw a horizontal line. Now, does this go through the point 2, 2? Absolutely it does. Does it have a slope of 0? Yes. Y equals 2 is represented there. Pretty neat, pretty neat. Let's go back to the example that we used earlier. We came up with y plus 3 equals 1/2 x minus 2. Okay? And so how do we then graph this? How then, if I gave you this equation, how do we graph this equation? Well, we're given a point. When I'm looking at this, I can derive what the point is. I can look at this and say, okay, my x is 2, my y is negative 3, so I can go to the point 1, 2, 1, 2, 3, negative 3. That's my point. And I know my slope is 1/2. So I can go up 1 over 2 to find a second point. Draw a line. And that's the line for that. Does that make sense? I found my point. I then took my slope and applied it to find a second point. 2 points make a line, draw a line, connect the dots. Additionally, what you can do is you can take this and convert it to y equals mx plus b, to a slope-intercept form. How can we convert it? Well, we just need to isolate y on our left side. So if I have y plus 3 equals 1/2 of x minus 2, I have to distribute this 1/2. So y plus 3 equals 1/2 x. 1/2 of negative 2 is negative 1. I subtract 3. So I have y equals 1/2 x minus 4. And sure enough, 1, 2, 3, 4. That's where it crosses. That's my b. I go up 1 over 2. I have my slope. And it's the exact same line. So there are multiple paths to be able to graph it, depending on where you're at. Yeah, Gracie. Because I'm just subtracting 3 from both sides of the equation. I'm not multiplying, so I don't have to. It's just minus 3. So negative 1 minus 3 becomes a negative 4. It is being applied to that 1/2 x. It just doesn't change it because it's a different term. It's an x term as opposed to a constant term. Questions? Comments? Do you guys want to see one more example, or do you feel pretty good? Thumbs up, you feel pretty good. Thumbs down, you want to see another example. Question?
So what happens if, like, you don't get given a slope at all? It just gives you, like 2, 2 or 3,
So one of the things, if I don't give you the slope at all, something I might, and I don't think it's on today's homework, but something that I will do in the future is I'll give you 2 points. I'll say like 2, negative 3, and then 4, 1, and I'll say write an equation that goes through these points. And so we have points, but we just need slopes, right? Well, luckily we know how to find the slope. We have the slope theorem. Delta y over delta x, which is y2 minus y1 all over x2 minus x1. So I can just apply this. y2 is 1. y1 is negative 3. x2 is 4. x1 is 2. 1 plus 3 is 4. 4 minus 2 is 2. 4 divided by 2 is 2. So that's my slope. So now I can write it in point slope form. I have y minus y1 equals m times x minus x1. So y minus a negative 3 equals 2 times x minus 2. Now you might be thinking, well, Victor, you used that first point. Can I use that second point? Well, let's find out. So if I were to use this second point here, well, then I would have y minus 1 equals 2 times x minus 4. And when you look at those, you might be saying, Victor, those aren't the same thing. Those are clearly very different. Well, let's find out if they're very different. Let's convert both of these into y equals mx plus b and see what happens. So if I distribute this 2, I get y plus 3 equals 2x minus 4. If I subtract 3 from both sides, I get y equals 2x minus 7. Okay? I'm going to do that on this side too. I'm going to distribute my 2. So I have y minus 1 equals 2x minus 8. I'm going to add 1 to both sides. Y equals 2x minus 7. And sure enough, they are the exact same thing. So even though these representations look different, they are equivalent. They are communicating the same relationship. This here, this here, this here, this here, they're all communicating the exact same relationship. These are all equations of lines that pass through those 2 points. Multiple paths to victory. Questions on that? That is something I will show you much later down the road, though. Or I'll expect of you much later down the road. For right now, I just want us to get comfortable with the form. I want us to get as comfortable as we can with this bad boy right here. There you go. Point, slope, form. All right. Final thoughts or questions? It's a new wrinkle. This is like prime candidate for things to write on a note card when it comes time for a test. Something to add to your catalog of knowledge. Make sure this is in your notes. Make sure you got a nice big box around it so you can find it later. Today's homework is essentially this. Just making sure that you guys understand that relationship. And that's going to be it, man. Go ahead and stop this thing. You guys can get to work. As you need help, go ahead and ask me questions. Use each other. And go from there.